morning friends. Today we will be going to see about Mohr circle. My name is Dr. M. Parvez Ahmed. So, before going to see about Mohr circle, we will have to be familiarized with some basic concepts, like basic terminology we have to understand. Few among them are uh, biaxial state conditions, biaxial stress condition, principal plane, principal stress, maximum shear stress, angle of principal in plane stress. So all these things you have to understand before understanding Mohr cycle. So first thing is biaxial stress. Uh, it is nothing but we know about uniaxial stress. When we apply a load in one direction, we call it as uniaxial stress. When we apply in both the direction, then we call it as like x and y direction. So both the direction, if we apply the forces, we call it as uniaxial stress. Sorry, biaxial stress condition. So in this case, what we are going to see is, let us see here. So this is one element of any mechanical member, so which is subjected to the tensile stress at one direction, which is sigma x, and tensile stress at one more direction, which is sigma y. So this condition is called as biaxial stress condition. Now next one is the principal plane. It is nothing but the plane in which there is no shear stress acting on this. So this plane is called as the principal plane. Okay. So now we'll see about principal stresses. And the principal stresses is nothing but it is a plane on which only normal stress is acting. So there is no shear stress acting on this plane. Let us consider this stress. So this stress is normal to this plane, and if you see, this is normal stress acting on this plane, and if you see, there is no shear stress acting on this plane. So therefore this stress is called as the shear principal stress. And here also you can see a similar case, sigma y if we consider. So this plane is the force acting on this plane is perpendicular to this direction, which is why we call it as normal plane, normal stress. And here the plane which is perpendicular to this stress is the principal plane. So therefore if we have if sigma x is greater than sigma y, then we call this as a sigma x as a major major principal stress, and we call this as a minor principal stress. Okay. So similarly, maximum shear stress, when we call it as this. So when we have when we apply a shear load, when we apply a load on this, there will be a shear. So that shear where the point of maximum shear occurs is called as the maximum shear stress. And so average stress is nothing but what are the forces, what are the stresses that is acting. Like here we see the normal stress acting at sigma x and sigma y. So average of this will give you the which is the average stress. Now we'll see about the analytical method for finding the principal stresses, maximum shear stress, angle at which this stress is acting, principal stress is acting, and the angle of maximum shear stress, the average shear stress. All these things are here. So let us consider about principal stresses. So principal stresses is nothing but it is the maximum stress that can be acting on a plane, and which is a normal stress generally, and there in that plane there is no shear stress acting on there. So therefore we call this as a principal stress. So now for finding the principal stress, we have to use this formula if we go for analytical method. So this formula, if you see here, sigma 1 sigma 2 are the two stresses, which is major principal stress and minor principal stress. Sigma 1 is the major principal stress, sigma 2 is the minor principal stress. So sigma 1 is here the difference is in sigma 1 we will be using plus symbol, and in sigma 2 it is the negative one. And maximum shear stress, you have the formula square root of sigma x minus sigma y by 2 whole square plus tau xy the whole square. Similarly, if you want to find the angle at which the principal plane is acting, so therefore we have to use tan 2 theta p is equals to shear stress along the axis by sigma x minus sigma y by 2. So similarly, the average stress is nothing but the sigma x plus sigma y by 2. So now we'll go for Mohr circle. So in the Mohr circle, we'll be having two axes. This is the graphical method for finding the principal stresses, maximum shear stress and angle of principal stress and angle of maximum shear. So all those things we'll be finding in the with the help of the graphical method. So for this, before proceeding this, we need to have, what we have to do is we have to draw two axes. Since it is a plane, the plane consists of two axes. One is the stress sigma, and y-axis is the tau, which is the shear stress acting on the plane. So now, in this first, what we have to do is we have to mark different points. So this different points are nothing but we do have what we have to do is we have to mark the point sigma x over here, sigma x, and sigma y over here, and tau xy here minus tau xy here. So then what we have to do is we have to find the center point of this. For finding the center point of this, what we have to do is we have to find the average of sigma x plus sigma y by 2. So that we have to substitute here. So this point is the center point, and based on this center point, so since it is what we have considered here is a case in which two stresses, normal stresses, are acting and a shear stress is also acting in this. So therefore this Mohr circle can be the procedure for drawing the Mohr circle for this type of condition is, so what we have to do is first we have to mark the center point, then we have to go for the plotting the point sigma x comma sigma y, so which is nothing tau y. Sigma x is here and sigma tau y is over here. So if you plot this, we'll be getting a dot on this. So this is the center point, and this is the one end of this point. So now next one is the third step is to plot the y point, which is nothing but the sigma y comma tau minus tau xy. So that if we plot, so we'll be getting a point over here. So then what we have to do is we have to connect this two points, this point and this point. If we connect these 2 points, we'll be getting a, and it will if we can say that this point is going through the center point. So now what we have to do is based from this either we take this as a center radius, or this as a radius, and this as the center point. What we have to do is we have to draw the circle. So that circle can be drawn according to this radius. So if we draw the circle, so it is since both the end will have the same radius, so therefore we don't have to worry about it. So now from this graph, this axis, this line is the tau. This is the tau what we have calculated, and this one is the sigma x. Okay, sigma x value, and this from here to here it is sigma y. So rest of the things are So this point, this intersection point along the x-axis is the sigma 1, which is the principal axis. So if we draw based on the scale, we'll be getting we can measure this value, and that value directly gives us the sigma 1, and this intersection point, so that intersection point is sigma 2, which is the minor principal axis. Okay, so then the angle between these two is, which is 2 theta, that gives you the angle of intersection, the maximum shear stress. So those things we can find it with the help of the sigma x, sigma y, we can see, and we can so this and if we go back, we can see that here you can see the principal axis is this sigma 1 is nothing but the center point plus the radius, that will give you the sigma 1. Similarly, the center point minus sigma radius will give you the sigma 2. And if you want to find the maximum shear stress, so then what we have to do is we can go back and we can see here. So this is the point at which we'll be having the maximum shear stress. So that we can calculate, that we can measure. So and we can verify with the help of the formula also. So based on this formula, which is the maximum shear stress is nothing but the radius r. So then the theta, how we are arriving at this theta is nothing but, if we consider this portion, so in this portion this is this is tau, and this is the value which is sigma x minus sigma y by 2. So therefore this value, which is nothing but the center, from the center point to the sigma x point. So therefore if we consider this as a triangle and this as a 2 theta, so then the tan inverse of this value will give you the theta p. So with the help of this we can measure all the there are two, as I told you, there are two methods. One is the analytical method, the other one is the graphical method. The analytical method, what we do is we use the formula for deriving the equation, finding the principal stress, maximum principal stress, minor principal stress, maximum shear stress acting on the plane, and angle of principal stress acting on the plane. So all those things we can find with the help of analytical method.